This is GMAETS 41, your channel of excellence. Remember, here you've got your NI assistance. We have this question here on the board. I'd like us to deal with it together. It's a physics problem, all right? Electromagnetic induction. A coil has 2,500 turns. The magnetic flux generated is given as flux equal to square of T plus 6T minus 7. Take note, this is a symbol we use for flux. Calculate the magnitude of the induced EMF at 2 seconds. Now, how do we solve this problem? One of the laws of electromagnetic induction is that given by Faraday. And now Faraday's law can be broken into two per se. Yeah, we have the first and then the second. We are interested in the second part of the law, which of course gives us the magnitude of the induced EMF when there is a relative motion between a coil and a magnet, whereby of course the flux that is linking the coil is changing with respect to time. According to him, the induced EMF is directly proportional to the rate of change of flux threading, linking the coil. Now, that law can be worked out mathematically to get an equation we call the Neumann's equation. Come along with me. Let us see how we deal with this question. So here we're going to apply the formula that the induced EMF is equal to N the flux dt. That's how simple it goes. I can fix my negative sign here. Of course, this negative, you don't use it in the calculation. You don't. The negative sign simply tells you that, the induced EMF drives the current in such a way that it opposes, the rate of change of flux that is producing that induced EMF. Anyway, this equation is what we are going to use, and we call this equation the Neumann's equation. It's actually obtained from Faraday's laws of electromagnetic induction. The second law, if you want to, separates the statement by Faraday in terms of electromagnetic induction. Now, what we have to do is simply, we have the number of turns here given to us, 2,500 volts. Number of turns, 2,500 turns. Okay, we have the number of turns, 2,500 turns. Now we are to get the rate of change of flux. We are given the flux here in terms of time. So you can say that, use your knowledge of differentiation. Let us obtain, we have that N is 2,500 turns. And then we can obtain our rate of change of flux. Okay, so we have this to be T squared plus 6T minus 7. Solving for the rate of change of flux that is threading the coil, we are going to differentiate this. See why you have to take your calculus seriously, okay? Physics, electromagnetic induction. Now, calculus is there in differentiation. This is going to give you 2T plus 6. And then at T equal to 2 seconds, you substitute. If you substitute, this is going to give you 2 bracket 2, then plus what? 6. Let me indicate T equal to 2 as given in the question. So this rate of change of flux will now be equal to 10. The unit is Weber per second. The unit of the rate of change of flux, Weber per second. And our problem is as good as solved, because what we now have to do is to go and substitute into this Neumann's equation an extension of Faraday's law of electromagnetic induction, and then determine the induced EMF, its magnitude. So we go. In place of number of turns, you have 2,500. We multiply it by the rate of change of flux, which is 10 Weber per second. 2,500 times 10. And of course, if you multiply this, you get 25,000 volts. And this is the magnitude of the induced EMF. The correct option here is option what? A. I hope you enjoyed this, right? That's good. If If you're yet to subscribe to this channel, subscribe and turn on the notification bell. You can also become a channel member on this channel. Join on platinum or diamond level in order to get coached, prepared for your exam. Remember, if you become a channel member, you get more benefit, especially for video lectures specially made for channel members. I'd like you to solve this next question as fast as you can based on the knowledge of what I've explained here. Click on this to take the question.